We are doing a grade 11 IT or information technology practical exam or paper 1 for November 2022 that I created. So hopefully this can help you prepare for your exams. And we are starting off with question 1, which is some basic grade 10 work. So let's get into it. Our basic scenario is you are an IT and systems manager for all the people and creatures of Longitudia, an enchanted magical kingdom, and you are asked by the resident wizard to modify the current software that manages and provides information on the events, magical items, and inhabitants of the land. That's our scenario. We are an IT manager for a magical kingdom. Quite cool. We've got magic combined with castles, basically. We've already opened up question Q1, so this is what the form looks like. So let's look at what the first question is. It's going to be very simple stuff in the beginning. It's basic grade 10 revision work. So let's go and look. 1.1. Complete the code for BTN Q11 button that modifies the following objects as follows. So we first want to display that text in the form's title bar that's displayed at the top. So let's start off with that. Let's go straight here. So when we click on that button there, that's Q11. So let's double click on it. Here's the code. So first thing we want to do is modify the form. So the form is called FRM question 1. That's the name of the form. And we want to change the title, which is the caption property at the top. And that must equal to what string? They said it must equal to question 1 mystical mode. Because I've got this in digital format, I can just copy and paste it. There we go. So we want it to be question 1 mystical mode. So that's the first part that we want to do. The second part, we want to change the color of the form to fuchsia. So remember, our colors start with a CL. So the color of the form. So we're going to say the form question dot. Now, if we say dot color, there we can see dot color is equal to CL fuchsia. How do you spell fuchsia? There we go. It's with a C. And then display the JPEG file, Dragonfly, in the IMG painting image component. Okay, so this is slightly different to how the other ones have been working. So we can say IMG. So that is the image painting. Now you want to change its picture. So you go dot, there is a picture property, and you can't make it equal something. No, it's very similar to dot lines or add. It's dot load from file. And then in brackets here, we must give it a string of the file name. Hopefully the data file is inside. There it is, the dragonfly.jpg. That's inside of your files, wherever your Delphi program is. So you want to make sure that it's there. So we're going to say dragonfly.jpg. Double check if that's the one they want. Yes, they want it to be the dragonfly image, and we need to double check what type of file it is. And you saw there that it was a .jpg. If you're not too sure, you can always right click on the file, go to the prop, and see what type of file it is. And then the last thing is disable the BTN Q11. Disable it. There is no disable property. There's an enabled property, BTN Q11. So we must set enabled to false if we want it to be disabled. Let's double check and see if this all works. We're going to run it. And let's click on the button. Boom. There we go. Change the picture. We can see the captions changed. This has been disabled. We can still see it, but we can't click on it. And the background's been changed to like a pinky color. So there we go. We know that it works. So let's move on to the next question. Question 1.2, complete the code for BTN Q12 for that button that takes as input the number of bottles of magic potion ordered via the SPN bottle spin edit control and calculates the number of baskets needed to carry the bottles. Now we can fit 7 bottles in one basket. Any leftover bottles, like let's say you've got a group of, after the group of 7 has been accounted for, must be placed in its own basket, because obviously you can't get half a basket, so you still got to get another basket for whatever's left over after 7. So they give us a hint to round up the answer. So for example, if there are 18 bottles are ordered, then there are 3 baskets are required, because 7 goes into 18 twice, because there'll be 14, but then there'll be 4 left over, and that needs its own basket, if that makes sense. And then we must display the answer using a message DLG that looks like this. So look at the message DLG. You'll notice that it's an information one, so that's going to be an empty information. There's the text, and you notice that there's only one button, an OK button. So let's see how we do this. So I'm at the code for it. I can click over there. You can see there is the SPN bottles spin edit. So let's first do the input. I'm going to create a variable for the number of potions that we want. Our bottles, which is going to be of type integer, because we're getting it from a spin edit. So our bottles is equal to whatever's in the spin edit. Now, how do we get the value from the spin edit? I just gave you the clue there. It's dot value. And we want to calculate the number of baskets. So our baskets, let's go look here. So our baskets is equal to the number of bottles, and we can fit 7 bottles in each basket. We're going to divide it by 7. That's going to round, well, it's not going to round up the number. That's going to give us like 18 divided by 7 is going to be 2 point something. But we want to always make sure we don't want to round the number because we don't want it to go down or up. We always want it to go up. And in that case, we want to go to the ceiling of the number, which means we're going to use the ceil function. Okay, there we go. So the ceil function. Now, when you are using the ceil function, just a little tip, always remember right at the top, make sure that you've got math included. Our baskets equals to the our bottles greater or divided by 7, and we round it up, and then we must display it in a message DLG. Message DLG. Now, how do I do a message DLG? First of all, I need to have my string that I'm displaying, and there you can see you need how many baskets. So let's go. You need our baskets. So that's my first parameter, and you'll not remember this is a integer, so I must convert from an integer to a string. Okay, so that's my first parameter. My second parameter is what type of message GLG is it. So I'm going to empty control space bar, and what type is it? I think it's an empty information. Now it gives you that full name, but we can say empty information. That's the next bit, and I know it's empty information because it's information 1. There we go. Then I need to get that button. That's an OK button, so I'm going to go, that's MB OK. We normally put that in square brackets because there might be multiple buttons, and then we just give it a 0 as the last parameter. So display a message GLG, there's my message, that's the type of 1, and that's the button that I want. Let's go test it out. You'll notice I didn't do any conversions on our bottles because that's an integer and the value returns an integer. So 18 we know should be 3. There we go, you need 3 baskets. If I get to 14, it should be 2 baskets exactly. But the moment I get one more than 14, that means I've got 7 plus 1 that's left over, that must go into its own basket, and it jumps it up to 3. So there we go, it is working. Great. Let's move on to the next question. 1.3. The evil wizard Lord Prime controls all 2-digit prime numbers in the land. And we know a prime number is any number with 1 and itself as a factor. In other words, it's got 2 factors. Special codes given to inhabitants of the land cannot contain any 2-digit prime numbers. Complete the code Q13 that takes as input a code via EDT code edit control and displays all the 2-digit prime numbers contained in a memo control. So if we look at that code there, you will see that 73 is a prime number. You'll see that 37 is a prime number. 78 is not because that's an even number. And then 89 is a prime number. So there are 3 prime numbers in that code. Because this number contains prime numbers, it is invalid. So we need to display in a show message if the number is valid or not. So it's valid if there's no prime numbers, but it's invalid if there are any prime. And it can be any length. You'll see that's any length code. Okay, so let's see, how do we do this? Now, this is quite complicated. We're checking a whole bunch of prime numbers every single time. My suggestion, let's work out one prime number, and then let's see if we can repeat that for every single number that we can. Okay, so that's my suggestion. So there we are at the question 1.3. There is our EDT code. So let's first get the input variable. I'm going to keep the code as a string, and we can always convert it to an integer at another stage. So S code equals to whatever's in EDT code dot text. There's no need to convert because I've still kept the code as a string. So I want to first check the first 2-digit prime number of that number. I want to get the first 2 digits. So I'm first going to get the first 2 digits and work out if that's a prime number. That's what I'm going to do. So I'm going to make it rnum. And that number is going to be, rnum is going to be copying from S code starting at 1 for 2 characters. So give me the first 2 characters of the code, and I want to convert it from a string to an integer. Okay, I want it as an integer because then I can do some calculations and mathematics on it. Okay, so let's work out. So in this case, from a string to an integer. And we want to work out if rnum is a prime number. So in this case, if you see that 73789, we are just looking at the number 73. We're just looking at that one. So, first of all, there's an error there. That's because you made rnum into a string. We mustn't make it a string. We want that to be an integer. That's going to be an integer. And another integer I'm going to need is I'm going to need to count the factors So I'm going to have an R count factors, and I'm going to have a looping variable. So there's my integers. So there we go. That makes that work better. And I'm going to initialize my factors to a 0 because we start off with 0 factors. And we are going to loop. Now, if I'm looking at the number 73, I'm going to loop from 1 until 73 to find all the numbers between 1 and 73. If I go above 73, there'll be no more factors because obviously it's bigger than the number. So I just need to loop for r equal 1 until that's 73, or in this case, r num. I'm going to keep doing this. What am I going to do, Mr. Long? I'm going to go through each and every number, 1, 2, 3, 4, and check if they are factors. And if they're a factor, I'm going to increase our count factors because that means I've found a factor. If I'm checking if a 1, a 2, do I have a variable that's going 1, 2? Yes, I do have r. R is my variable that's going 1, 2, 3. I'm going to check if r is a factor of r num. In other words, if I take r num and I divide it by r, to determine if it's a factor, it must have no remainder when I divide r into r num, which means I don't want div, I actually want mod, because mod gives me the remainder. If that equals to a 0, that means if r goes into r num and there's nothing left over, it goes into it equally, then I have found a factor. If that's the case, then increase r count factors, because we found a factor. If it's not a factor, then just move to the next number inside. That's all I want to do. And then if that is completed, once the loop is done, because I can't tell if there are 2 factors or not until I've done all of the factors. So that's why I've got to go outside of the loop. That's the end of the loop, end of the for loop. Now I've got to go outside it. Once it's done, only once it's done, can I say if r count factors equals 2. If that equals 2, that means we have 2 factors. Then that's a prime number. If that's the case, then I'm going to display that number in this memo control, mem display. So let's see. So mem display dot lines dot add, and we're displaying r num because r num is a prime number. But remember, r num is a integer, and lines dot add in the member control needs a string. So we're going to go from an int to a string. So this only works out the first 2 digits of our code. So let's just test it. It doesn't work out all the 2-digit numbers. It just works out the first 2 digits. So there's my program. So we are just checking if 73 is a prime number. If I change that to 74, that means the first 2 digits is not a prime number. Would display nothing because it's cleared the member control before it did that. So we got it working for the first 2 digits, but that's not what we want. We want it to work for all the 2 digits. So we want to copy from 1 to 2, and then from 2 to 3, and then from 3 to 4. So we want to go, and we actually don't know how long the code's going to be. So I want to do this every single time for 1 to 2, 2 to 3. So let's think about that. I am going to loop through this code, and let's say this code is 737489. Let's say it's like, so it's 1 and 2, then 2 and 3, then 3 and 4, then 4 and 5. So I'm always, if you think I'm going 1, 2, 3, I'm looping through all of this again. So I'm going to take all this code, everything, the entire code. So in this case, we're going to go from there to there. So we're going to go through the length of the code. So I'm going to loop. So I'm going to do all of the stuff. This is the calculation for a prime number. So there we go. That's the prime calculation. I want to repeat this whole thing. So make sure that we encapsulate everything inside its own loop that's going to go through each and every one. So how do I do that? So I need another looping variable. This is a nested loop. So I want to make this J. So remember, this is J. So we are going to loop for J is going to start at 1, and we're going to go from 1 until the end of the code string. So we're going to go 1 until the length of the string is code. Okay, and we're going to repeat all of this. Go from begin, and then that's where we put the end. So this is the end of the J outer loop. And this is the end of the R inner loop. So all of this. So I'm going to indent this a little bit just so we can see the difference. So there we go. So let's think about this. I don't want to work out 73 every single time. I want to work out, let's think, if that's the code, we're going to copy from 1 for 2 characters. So let's make some notes here. For 2 characters to get the 73. Then for the next number, we're going to copy from position 2 for 2 characters. And then for the next number, we're going to copy from 3 for 2 characters. And then for the next number, we're going to copy from position 4 for 2. So are you noticing? First of all, take notice of 2 things. The second parameter is always 2. So we are always copying 2 values. But this number here will be a 1, and then a 2, and then a 3. And then do we have a variable that's going 1, 2, 3, 4 for all of those numbers? That's the j value. So I'm going to take that 1 and replace it with a j, because then it's going to be a 1 and copy from 1 to 2, and then j becomes a 2 and copy for 2 characters, and then j becomes a 3 and copy for 3 characters. That's going to be able to go through all, there we go, from there to there, from there to there. That's going to copy all my 2-digit numbers in my code. However, there's one thing we need to change here. You'll notice when we copy 2-digit numbers, when I get to the last one, you'll notice I'm not actually going from 1 until the length, because if I go to 1 and then I go to the length, if I get to that 9, I cannot copy 2 characters from that last character for 2 characters, because there is no character after the last one. I can only go to the second last one and copy 2 characters. Do you see that? So the slight modification I'm going to do here is I'm actually not going to go from 1 to the length, because I'm copying 2, 2, 2. I'm actually going to go from 1 until the length minus 1, because when I get to that 8, I'm going to copy for 2, so it'll be 8 and the 9. I'm not going to copy 9 plus whatever's after 9, because there's nothing there. So I'm actually going to go from 1 till the length minus 1. That's more efficient. And we're going to keep doing this and display all those numbers. So let's see if that works. Let's click on the check for prime. We want to check how many prime numbers are there. Boom. There we go. It picked up the 73. It picked up the 37. It did not pick up the 78 because that's not a prime number, but it did pick up the 89. So there we go. It's working. Now, what's the next part of that question? We need to show a valid or not valid in a show message if it's valid. So if there's no numbers in the memo control that's been displayed, then we know that it's valid. But if there are numbers there, then it's a problem. So we need to count how many prime numbers we found, basically. So I'm going to make a variable here called count prime. And at the very top, we are going to initialize our count prime to a 0. We're not going to do it inside the loop. We're going to do it outside the loop because we want it to be 0 from the very beginning and then continue adding onto it. We do want our count factors to be a 0 inside of the loop, because when we go from 73, when we count those factors, we want to start it at 0, but then when we move to 37, we want to reset the factors to 0. We don't want to include the factors from the previous number, so that's why that one is inside the loop, but our count prime is outside the loop because this incorporates all the calculations, and every time we find a prime number and we display it, we are going to increase that prime count, our count prime, and then at the end of the outer loop we can say if our count prime is equal to 0, that means that we found no prime numbers. Then we can show message valid. They don't actually give me a message to display, do they? Let's have a look. Do they give me? They don't tell me. They just say whether it's valid or not. So we're just going to display the word valid. And if it's not a 0, that means it's obviously a 1 or a 2 or a 3. That means we found a prime number. Then I'm going to say show message not valid. Because Lord Prime has stopped us because it's got a 2-digit prime number there. Okay, so there we go. So let's test that out. But before we do that, let's first close that bracket, Mr. Long. There we go. Don't need to. There we go. And then let's run it. Okay, let's try to run it. Not valid. Yeah, we know that it's not valid because there are 3 prime numbers. Now, if I gave it all even numbers, so those are not prime numbers because they are even numbers. So none of those will be prime numbers, but we're going to add a 41. I think 41 is a prime number. So let's try that. There, it picked up only the last digit as a prime number, so it's not prime. There we go. And then let's try this number. Let's try this number, which we know, according to the example, does not contain any prime numbers. Valid, there's no prime numbers. There we go. So there we go. Now we know that it's working. That's how we do that question. So remember, the key to this question, It's very confusing. Is first to get it working for one prime number, because you know you're doing a loop from 1 to r number for that particular number. And then you're going to encapsulate that entire code for one prime number into another loop that's going to check for all prime numbers. So this is a nested loop example. And the last question, complete the code on the form's form create event handler that adds a button to form as a dynamic object, and it must have those properties. And when the button is clicked, the form must be closed. Okay, so let's first of all, we are going to go to our top of our program, to our variables over here, and we're going to declare a global variable button. I'm going to call it btn temp of type t button because it's a button. Okay. And then on the form create, if I scroll, I think there is a form create. Here's the form create. We're going to write the code here. So what are the steps? First step is we must instantiate the button. So I'm going to say btn temp dot create. No, don't do that. This is the only step that's slightly different. You're going to say it's equal to what type of object is it? It's a t button dot create. And who's going to own this button? The button is going to be owned by the form. So frm question 1. They're going to be the one who owns it. Great. I'm going to give it some properties. I'm going to use the with clause, with btn temp do, and in the begin and end. Remember, if you've got with, you must have begin and end if you can do multiple things. We're going to set some properties. We're going to set the left and the top. So we're going to say the left is equal to 24 and the top property is equal to 282. Now you'll notice I'm not saying btn temp dot left because I'm using the width. If I didn't use the width, I would have to go btn temp dot left equals this. Both of them are correct. I'm just doing this as a quicker way of doing it. We need to, the width is 209. The height is 41. The caption is close this form. The font size is 12, so the font dot size equals 12. And the one property, you'll say that's all the properties, but the one property that we still need to specify is the parent, because we can't have an orphan object. So the parent, who's the parent of this button, and that is my form, frm question 1. So they are the parent of this form. So let's try that quickly. So when the form gets created, there's my lovely little button that's being created, but when I click on it, it does nothing. Okay, so now how do I get it to do something? What do they want me to do when I click on the button? It must close the form. So what I'm going to do is I'm going to create a procedure. So I'm going to make my procedure look very similar to these other button procedures. So I'm going to make a procedure. I'm going to call it button clicked. You can give it whatever name you want, as long as it matches what these other buttons look like. And I need to give it a sender object of type T object. It must have the same parameters as what other buttons have. So there's my procedure, button clicked, and it also has a sender T object. I'm using that as almost like a guide to tell me how it must look. And I'm going to write the code for it. Go Control Shift C. Now I'm at the code over here for when this button gets clicked and I want the form to close. So I'm just going to call the close procedure, or caps lock is on. Close. There we go. So close this form, and when the button gets clicked, it must run this procedure. I'm going to come over here, and one of the properties is that the on click event must equal to the button click procedure. I think it's button clicked. I call it button clicked. Button clicked. Match up the on click the procedure with the button click. So when I click on it, it's going to run here and run this code, and it matches the same. So let's run and see what it does. If I click on this form, close this form, boom, and there we go. The form has been closed. So there we go. We've done our dynamic object. So let's move on to question 2. For the other videos in this series, make sure that you go to our YouTube channel, click on that playlist option so you can see all the options available. Click on that subscribe button, leave a like, leave a comment. We'd love to hear from you. And remember, don't do it the long way. Do it the Mr. Long way.